Good morning students, welcome back to the class. Next topic, continuing our moment of inertia unit. Next topic we are going to discuss about the moment of inertia of a ring about an axis passing through its center and perpendicular to the plane of the ring. Means if this is the ring which is lying in xy plane, x, and here I have y axis, then moment of inertia we have to find it at about z axis. What I mean to say is, if this is a ring and this is, let this be x axis, this be y axis, and we have to find the moment of inertia about an axis passing through the center and perpendicular to the plane of the ring. So since I have to find the moment of inertia perpendicular to the plane of the ring, so just recollecting our algorithm, that first we have to choose the coordinate system. So here we are using, since we are considering a ring, so we will be using plane polar coordinate system. I am repeating, plane polar coordinate system. So further, during this we have also to define the n cap. In this case we have to find the moment of inertia about z axis. So our n cap is equal to k cap, because we have to find moment of inertia about z axis. Okay, considering the next step in algorithm, that we have to define a mass element dm with its position vector r. So what I do is, I consider the mass of the ring as m and radius of the ring as capital R. So what I mean to say is that here my radius of the ring is capital R, and let us say if I am considering this ring and I have to consider a small element. So I consider a small element AB, okay, such that AB is making angle d theta amongst itself, and also the position vector of this OA is R. This position vector of this DM is R, and this R is making an angle theta with x axis. So obviously R will be equal to R cos theta I cap plus R sin theta j cap, because this R is making angle theta with x axis. So considering its component, along x axis component will be R cos theta, along y axis component will be R sin theta. So if lambda is the linear density of the ring, and let us consider dl is the length of element AB. So our dm will be equal to lambda dl. So dm is equal to lambda dl, which is further is equal to, because lambda is the linear density means mass over total length. So total mass is m, total length is, because r is the radius, so circumference of a circle is its total length, into dl. Also, if I see the figure, this AB length of AB is dl. So recollecting the mathematics that you have done in class 10th, so dl is equal to r small r into d theta. So dl is equal to radius r into d theta. So substituting this value of dl here in this equation, we get dm is equal to m over 2 pi r into r d theta. Remember, we have small r and this d theta because we are choosing plane polar coordinate system, which was the very first step of finding the moment of inertia. So this r cancels. So we have dm is equal to m over 2 pi into d theta. So recollecting that, what is our third step? Our third step is that we have to find the value of di, which is equal to n cap cross r vector square into dm. So first of all, we will find the value of n cap cross r. Remembering that n cap is equal to, we see that here n cap is equal to k cap and r is equal to r cos theta I cap plus r sin theta j cap. So n cap cross r vector, that is k cap cross r cos theta I cap plus r sin theta j cap. K cross I is j cap, whereas k cross j is minus I cap. So n cap cross r, this comes out to be r cos theta, k cross I is j cap, minus r sin theta I cap. Since we have to consider its magnitude, so n cap cross r, its magnitude, and considering its square, so it comes out to be under root of r cos theta whole square plus r sin theta whole square. This is the magnitude, and further there is a square of magnitude, so this is like this. So our result comes out to be r square cos square theta plus r square sin square theta. It's under root and it's square, so this cancels out. So our result comes out to be r square. So we have to put this value of n cross r square, that is r square, in the value of di. So here I get di is equal to r square, and we know that r square, n cross r square dm. So we have to put the value of dm also, that is m by 2 pi into d theta. So into m by 2 pi into d theta. So to find the total moment of inertia, we need to integrate it. And just recollecting, as we did in previous article, that we considered the length from minus L by 2 to L by 2. So since here we are considering a circle, so total angle of a circle is 0 to 2 pi. Okay, so we have here, since it's d theta, we will be considering 0 to 2 pi, the variation. Rest m and r is constant, 2 and pi is constant. So I is equal to integration of di. Because these things are constant, these things will be taken out of the integration, and 0 to 2 pi d theta. So integration of d theta is theta. So we get theta, its value from 0 to 2 pi, limits. So m r square over 2 pi into 2 pi, this cancels out. So our result is m r square. So the moment of inertia of a ring about an axis passing through its center and perpendicular to its plane, means if ring is lying in xy plane, then the axis is passing through z axis. So its result is m r square. Hope you enjoyed this lecture. In next lecture we will be discussing about moment of inertia of a disk. Thank you.